Okay, here we go. We are looking at quadratic equations. This is a practice task, and we're going to study it well and get ready for our assessment. Okay, so question 1. We've got 2 points, point A and point B. So let's form a line segment between A and B and calculate the following. So imagine 2 points connected with a straight line. What is the gradient of that straight line A to B? Okay, so gradient is worked out using this rule. Change in y divided by change in x. And so using our coordinates, we get the difference in the y coordinates, divide difference in the x coordinates. You've got to be careful with making sure you're subtracting in negatives, and that becomes an addition. And we get negative 12 on 6, which is a 2, negative 2. Now, part B, the equation of the line segment. So we use this, y equals m, x minus x1 plus y1. Okay, so we use our gradient, what we've worked out previously, and one of the coordinates. So we're going to be using this one, minus 3 and 5. So let's substitute there for x1 and y1. And we expand and we add up the units. There it is, y equals 2x minus 1. And then the length of a line segment, well, we use this formula. Okay, the difference in the x squared plus difference in the y squared, and then square root. So we substitute in our x coordinates and our y coordinates, and make sure here this is a 3 subtracting negative 3, which is an addition of 3's, so it gives you a 6. And we square each number and square root, and we get, there it is, square root of 180, which is 6, root 5 units. And then the last part is the midpoint of the line segment. So there's our formula for the midpoint. You add the x units, divide by 2, and then you add the y coordinates, divide by 2, and so on. So you should be getting 0, negative 1. Okay, question 2. Let's factorize the expressions. Alright, so this is a difference of two squares structure, 32 minus 8x squared. So we get the square number of both parts. So to make 32 a square number, you've got to square root 32 and then square. And then we put it in the difference of two squares pattern and then simplify the thirds. Just like so. Alternatively, we could recognize, hey, we've got a common factor in each terms of 8. So we're going to take out a common factor of 8 first. And that leaves us with a 4 minus x squared. And then we do difference of two squares. 2 minus x, 2 plus x in our brackets. Which one do you think is looks better as a solution? It's definitely this one, working with whole numbers. So the important thing is look at factorizing highest common factor first, and then do difference of two squares. Okay, then we have this one. We're going to factorize a 2y squared minus 3y minus 9. Okay, well, we use the AC method, so 2 times the minus 9 gives you minus 18. So what are factors of minus 18 that can add to give you a negative 3? Well, that's a positive 3 and a minus 6. Okay, we express this minus 3y in terms of the two parts we found, a 3y minus 6y. Okay, now rearranging them the other way, then we make a pair of the 2y squared minus 6y. That's a good pair there. And then the 3y minus 9. Take out factors of 2y from the first two, and a factor of 3 from the second two. And we get this, and then there's another common bracket factor of y minus 3 as a common factor, and let's take that out. There it is, y minus 3 times 2y plus 3. Okay, then we've got question 4, solve the equations. Okay, so part A here is double brackets multiplying, that is equal to 0. We use our null factor theorem. So that means that the first bracket is equal to 0 or the second bracket is equal to 0. And we solve each little equation for x. X equals 2, or we get x equals minus 5. Okay, next, quadratic that is equal to 0. So the first thing you do is always check what are factors of 30 that are going to add to give you negative 11. And we have a pair. This is here, negative 6 times negative 5 gives you positive 30, and adding them gives you negative 11. So then we can use them and factorize into double brackets like so. And we solve and we get x equals 6 and x equals positive 5. Okay, now the next equation, when we solve first, see if you can factorize highest common factor. And there is one, 2, 8 and 4, highest common factor of 2. So factor comes out. Now this is 2 times something equals 0. So that means the bracket part must equal 0. So we can divide both sides by 2. And we just get this, x squared minus 4x minus 2 is equal to 0. So now we can go ahead and complete the square. Okay, so half of the coefficient of x, half of minus 4 is minus 2, and we square that number, add it in and subtract it. And then the first 3 terms gives you this perfect square, x minus 2 all squared, and we've got 8 minus 6, and that's equal to 0. Add the 6, then square root both sides, don't forget the plus and minus, the square root of 6, and then finally we add the 2 to the other side, and there's our solution. Question 4. Complete the square for the following quadratic expression and write in factorized form. Okay. So completing the square, half of your coefficient of the p term, okay, and you square it, you add it in, subtract it, there it is. Then you get your perfect square, and we've got a minus 9 on 4 and then subtract 6. So let's get this whole number 6 as a common denominator with a 4. Now this is a negative 9 subtract 24, and it gives you a negative 33 altogether. Now when we write in factorized form, we're aiming for double brackets. So by looking for double brackets from this, we recognize, hey, we've got a difference of 2 squares. This is a squared number here, but making it the square root of that result, all squared. And voila, we end up with double brackets that are equal to 0, and then we solve separately by doing the adding and subtracting the terms to the other side of the equal sign, and we get these two sides. Very good. Make sure you write the sides with this common denominator of 2. Okay, question 5. Sketch the graph. So the graph is given to you in turning point form, and we're going to work with that one. So first is the y-intercept. That occurs when x equals 0. So we substitute a 0 for the x and evaluate. 2 times 4 plus 3 is equal to 11. So there's your coordinate, 0, 11. Okay, what about x-intercept? We make y is equal to 0. So let's substitute y is equal to 0 at the end. Now let's solve. So we have to subtract the 3, divide the 2, and then take the square root. But look out, we get square root of a negative number, and that's undefined. So we have no x-axis intercepts. That means the parabola is going to be above the x-axis, and it won't cross through it. And finally, our turning point. Now, turning point is read just straight from the equation. Remember, turning point is always the negative value of this number, the number 2, next to the x part, and the y coordinate of the same sign of the positive 3. So we get a negative 2 and 3 for your turning point. Okay, let's sketch. So plot those points, get the turning point in there. There it is. Get up here around about off the thing about 11. There's your y-axis intercept, and we will have no x-axis intercepts. And drawing it carefully, starting from the turning point, we get this graph. And we did it.